I would like to show you the very basic steps for preparing a dynamic simulation. As we have seen in previous simulations, the steady state simulations, what we have done is quite, basics. So I would like to show you an example on the dynamic simulation also. Without any training, it would really difficult to make a dynamic simulation. I would show you very basic steps and basic fundamentals of dynamic simulation. We first prepare a steady state simulation. Here I would like to add some components, air, some water. Air is dispersed into the water. When adding the component list, that is the basic step of steady state simulation or any simulation. You have to first include all your system components. What are the systems you have, how many components you have. Then you have to add a property package to the system components by which their thermodynamic property will be calculated. Nowadays this Aspen also have the facility to launch property because who can suggest you, but we are not going to use this nowadays. If something is not incompatible with the property package, it will show you the warning, and then you can select the different one. Here we have selected Wilson. Now enter simulation environment. Now I will put a separator here, two-phase separator. In the separator I feed here. That is a very fast method to create the simulation. You type here and the streams will be created there. Okay, not solved because I have not volume I should give. Okay, later we will give. So first I will give the values to properties. So my mole fraction is say 0.2. So temperature, say now I will leave the temperature. The pressure is 2 bar. Okay, and then molar flow is say 100 kg mole. Unknown composition. Okay, air is my 0.5, no 0.4, and say water is my 0.6. That is a mixed dispersed phase. Okay, now I can see the conditions. Temperature is minus 254. Yes, you have to maintain that temperature if you want this water and air, air to be liquid phase. Okay, now that is a steady state simulation. I'm getting 0 kg mole per hour here, and all water is here because my temperature is quite low. Okay, if I change the vapor fraction here, then 0.9, something like that. This temperature is increased, understand, because there is now less part to be liquefied. Anyway, now I'm getting the flow here and here. So okay, that is the steady state simulation. We are not going to discuss here. It is a very example case I have taken. This is not a real case. What I want to show is how to put the dynamic simulation here. Dynamic simulation, we first need the valves. There should be the valves in and out where we can do the control. Every system interface there should be some valve. For the simple system like this, it will not add the valve, we can add by ourselves. But for the larger system, sometimes dynamic assistant itself adjusts the valves, or we have to put the valve. Means the flow should go from higher pressure to the lower pressure. That is the pressure flow equation that needs to be understood. In steady state simulation, you do not care about the pressure flow. Even the pressure is higher in the downstream, still it will show a flow towards the higher pressure, which is not practically possible. Second thing is the volume. Everything you put into the system must have a volume. It cannot be infinity or something like that. So I have to put a volume always. Be careful about that. Now the I need to add the wall here. I add wall. Okay. Again here wall. I simply choose this is the air one. Now I will air save one. It will be automatically created, but I have not given the pressure drop across the wall. That is a right now it is a very I mean constant value I am giving, but later on the value will be changed according to the pressure flow, and that is also require a feed stream. Okay, I have not connected the feed stream. That is a water and then water one. Okay, and again here that is a catch. I have already so it cannot be added. I have already okay. Now the thing is that what I did, uh, the mistake I have is prone to be here. Like I have defined pressure here, and once I will give the valve pressure drop, it will back calculate the this pressure, which is not true. 250 it added because there is a 50 pressure drop, and here I need 200 pressure drop. But it is the problem here. It will not. It will back calculate the pressure. So the good practice is that I remove the pressure from here, and then I should give the pressure here. That is a good practice. Sometimes when you make a big solution, a big simulation, you make a distance mistakes like this. Now I have added the wall. I need to size the walls also. So percent opening for a good wall. I need okay size the wall. Get the conductance, which is not so good because my pressure drop across the wall is not so good. I if I have a more pressure drop across the wall, my controllability for the wall is good. So keep it in mind that this means you have a big ass valve. Okay, this valve is very good. Now the last step for the dynamic simulation is to put the control into the system. I simply put a PID controller here who will select pressure variable will be my V100 liquid percent level, liquid volume percent. Okay, and it will oh I'm not this valve 102, and it's operating with valve actuator desired pressure. Okay, now parameters it should be direct. The liquid level is more than okay. Once my liquid percent level could be from 0 to 100, that is the pressure process variable range. It you are supposed that is supposed to be happened. Now I put into the auto mode direct type. Set point is 50% right now. For the liquid level controller, I can increase TI by KC by 2, and TI is for any offset removable. Except the composition, we usually do not put TD here. I hope you understand these things. Now what I will do is I need to prepare the strip chart so that I can show you like this. Okay, so this is my basic controller. Now you will see I first need to create again. I have given the feed here, which is not good. Delete. I need to give the feed here only, and also composition from here I should remove 0.1. I need to give it here. All my stream boundary stream should be defined, not the internal stream. Internal stream should be by the unit operations, should be defined by the unit operations. Okay, now I will show the strip chart here. Dynamic strip chart, create strip chart. Okay, temperature, pressure value. I don't need temperature, I don't need pressure. I need only flow value here to be shown. Okay. Okay, now I will show you the valve faceplate here. That is percentage opening and pressure variable value. My water flow. That is the temperature. Okay, I don't need temperature, I don't need pressure. Create a strip chart here. Now we can also show this. What can we say is a show table, and here liquid percentage level is shown here. So you can see from here also I can see what is my liquid. Also I can remove these all. Remove variable. Okay, let's keep these variables only here. Now this is my dynamics. What is it? Should be pressure, or let the dynamics assistant decide us. Okay, or the disable pressure phase make changes. Enable steam flow specification should not be there. Okay, because I have already added the valves here. Now this is my molar flow. Yeah, pressure is okay. Now I start here. Cancel. Yes. Now you can show the flow. Stop this simulation integrator. I want to put the integrator quite slow. Real time factor say 20 only. It will slow up my speed of the. Now you can see here. So my now you can see auto scale curve. Now what will happen if I change my process variable here? Now you can see the here and this face plate here. So this is my dynamic simulation started. To remember the basic fundamentals, that flow always can go from higher pressure to lower pressure. So in your steady state simulation, whatever you made, you make sure that well into the dynamic simulation mode, your this pressure should be higher than the this pressure. Then only will flow occur, otherwise it will give you the warning that pressure occurring at negative size. Second, put the size of valves and the equipments, and third one is to put the controller at the right place with the right KE and DCs. Now here I can make the changes here like this. Suppose okay, molar flow, I don't know, say I decrease the water, it will control then water. Okay, it should close down the valve. 0.5. Okay, it is 0.5 now. So you can see the valve has been closing down because pressure variable is going down below set point of 50%. And again this you see my flow rate is gone down, so my water flow rate also go down, and this my pressure is this valve is also getting closed down to maintain the level. So thank you very much, gentlemen. I hope you learn. If you have any queries, please give me a mail. Thank you once again.